So this is TIG welding demo. In TIG welding, we use an arc welder. TIG welding is always done inside with ventilation. The T stands for the tungsten. The tungsten is the rod that's inside of the torch. So the tungsten itself, it doesn't melt. This is used to conduct the electric current to the surface. So the electric current is going to melt the steel, and that's going to allow you to fuse it together. So you always want to hover just above the surface without touching. So the tungsten itself, it gets damaged as you weld because it gets a little bit of the steel and a little bit of the filler and a little bit of oxidation on the surface. So the surface will look kind of dark and maybe will have a blob of metal on it. So these we sharpen with a bench grinder over there. And we just want to sharpen them like a pencil so they're a nice point. So I have some sharpened ones here. So it's normal to change those out while welding. If it's not easy to weld, you can switch out the tip for a sharper one. So we're going to leave it outside of the torch just far enough that we can see it, but not too far out that we'll have the gas flow. So the second half of TIG stands for inert gas. The inert gas is in the tanks here, and this is argon. So argon is heavier than air, so it's going to displace the oxygen as you weld and prevent oxidation and rust. So if your surface has rust on it, it's not going to weld because the rust will not melt. So you're going to have a lot of problems if you have any scale or any coatings on your metal. So you have to make sure before you weld that you make sure your pieces are machined tightly so they fit up really well and there's no gaps. And it's very clean. You don't want any oil, paint, scale, anything on the surface. So the samples we're going to use today are low carbon steel. So what we're going to be welding is called a butt weld. So that's just two pieces up against each other. And this is the easiest thing to practice. So what I'm going to do is I'm going to show you how to weld it, and then you're going to weld, and then when you're welding, you'll be able to see it a lot better than from a distance when I'm doing it. So it is really hard to teach welding. It's better to do it. So when you're welding, you set up your machine for your metal. So the metal that we're using, being a low carbon steel, we're going to use a DC negative setting, and we're going to set the amperage output, and this is going to depend on how thick your metal is. So these machines can't weld really thick metal. They have a limit on the amperage output here, and that's going to depend on which setting you choose. So when we're doing steel, we do DC negative. When we're doing aluminum, we do alternating current. And then you'll see there's ranges for the amperage. So that's going to change depending on whether you have a thin piece or a thicker piece. So the max on this machine is around 120 amps. So that's maybe half or lower than a maximum on a more industrial machine. So the bigger high-tech machines can go up to like 300 amps. So this is like for smaller stuff. Okay, so you have to make sure your gas is on. So when you open the gas tank, there's a regulator here, and that's going to show you how much is in the tank and how much is flowing. So you can only read what's flowing when you press the pedal. So when you press the pedal down here, kind of like a car gas pedal, the harder you press, the more amperage output you're going to get. And you're also going to get the gas flow. So the gas flow depends on what you set here. So if I grab this and hold it up in the air, I can test the flow. And then it gives me a readout on here. So I want this around 18 to 20 cubic feet per hour, so I can adjust with this knob. So then you're all set to weld. Okay? So I'm going to show you first, so it'll be a little quieter, and then I'll turn on the machine and weld, okay? So when you're welding, you want to be really close to your piece so that you can see. You're going to basically be looking right down the seam as you weld. So if you are really high up, you're basically looking down at the torch instead of looking at the seam. So that's why the chairs are really low, okay? And they are adjustable. So the first thing that I always do is get in position, hold this comfortably, and you can lean on the table. You want to tap this on the table like that, and that will break off any oxide that's on the tape there, and that will enable the arc to flow. So what we're going to do is all about practice today. So we're going to start with what's called a tack weld. And a tack weld is when you weld just one spot to fuse the two pieces together. So tack welds are commonly used when you're trying to build something and you want to arrange all your pieces, get them set up, tacked in place, make sure they all work. And if they don't work, you can grind them off really easily and make your edits and come back. The other thing they do is they pin it so it doesn't expand from heat. So if you start welding here, as you're moving down, the piece is getting really hot, and the pieces that aren't attached are going to spread out from the heat expansion. So what we're going to do is just tack the top. So I start to the side of the seam. If I start in the middle of the seam, it's going to make the seam open up and the gap wider. So I'm going to start on the solid metal just to the side. I'm going to push my pedal all the way to the floor because I have the amperage set that I need to melt this. I'm going to wait in this position. And when I see the fluid movement, then I'm just going to slightly move it across the seam left and right like that. So that'll be a tack weld, and it's really quick. So once we do that tack, we're going to do another tack on the other side, and we're going to go all the way down the seam. And that's going to be a fusion weld. So a fusion weld looks like this. So it's very flat, and if you actually look at it closely, it's kind of a little dip, because it's melting into the seam. So in order to increase the strength of your weld, use filler. So when you're adding filler, that's what looks like the raised, like, stack of dimes shape. So that's what we're going to do next. So the fusion weld is for practicing what to do with whatever hand you write with. And then when we do the filler, we're going to use our non-dominant hand to add in the filler. Okay? So the filler that you use, it depends on the metal that you're welding. So we have an assortment of filler rods, and they're all different alloys, and the alloys are designed to melt easily into the molten metal that you're welding. So it's nothing like soldering. We don't use this to melt this. The arc is going to melt the steel, and then the steel is going to melt the filler. So the filler will make an alloy with the steel. It will strengthen the steel, and it will fill in that little gap where the seam is. So it'll make your part stronger. So this is going to come in different thicknesses as well, and you can get a thicker rod if you have a thicker piece that you are welding. Okay? So when you're wearing these helmets, these work really well close up. They don't work as well far away. So they will protect you from people that are nearby welding, but it may be flashing a little bit if you're watching from far away. But it should stay dark green when you're welding when you're at the bench. Okay? So there's an on button on the inside. It's different for every model of helmet. And there's no off button. So it'll automatically sense that it hasn't had a light trigger, and it will go off within a half hour. So when you sit down to weld, you press the on, and you should be able to see through it, and it should be light green at this point. So if you look through your helmet, it should be light green, you should be able to see, and then as I start to weld, it will switch dark. Okay? So I'm going to adjust to the tack weld first. I'm going to start just to the right of the seam, push all the way down. When I see the pedal, I'm going to move across the gap, and then take my foot slowly off and keep moving it a little bit. So if you keep your torch there, it prevents the rust. As you're welding along and you leave, the area behind you will oxidize. So when you're welding, you never want to be going back and forth over areas that you've welded previously without cleaning them first. So we always go in one direction, and if we need to go back and fix anything, we want to clean it. So this tack weld, this is the only time you can touch it because it's only hot at that very end. Okay? So that's just as tack, just one spot. So now I'm going to do the same thing on the other side, and then I'm going to do the fusion weld all the way down. The main thing when you're holding the torch, you want to have it as close to 90 degrees to your workpiece as possible. You can tilt it up to 30 degrees back in any direction. But if you're welding along and you keep tilting it like this, your arc is going to travel in front of you. And you want to keep the arc really short because you're using a current going through gas. So the longer the distance is, the less power you have. So we want to keep it tight, keep the angle consistent, and keep the distance consistent. So we don't want to be going like this either. We want to keep it at the same height as we go along and at the same angle. Okay? So I have my tongue, and I'm going to do the tack at the top, and then the fusion down. So I still start to the side, get my pedal, close up the gap, and then I can move slowly down the seam. You just have to make sure the pedal is still there, and you're not skipping any spots, or moving too fast, changing your height, or changing your angle. When you get to the end, you're going to take your foot off slowly and move the torch. So this is what it should look like. Now it's too hot to touch, so I'm going to try to grab it. So it looks just like the one I showed you earlier that was cool. Okay? So it shouldn't be glowing very bright. If it's glowing a lot when you stop, then you work too slowly and you've overheated it. So this is likely to happen today because you're learning. The other side should not have any effect to the weld on it, so it shouldn't weld all the way through. The only way to weld all the way through is if you're doing a friction weld, a laser weld, or you've notched the workpiece so that you can start from the bottom and fill all the way up. So typically that's not required. It just depends on how strong you need your welds to be. Okay, so the filler rod has marks on either end, and these numbers correlate to the type of filler is used. And you want to have it pretty long because it gets short quickly. So start further back. If you start up close, you're going to have to stop really soon after. Okay? So we're going to be doing the same thing we did on the other side, except now I'm going to take the filler rod and I'm going to touch it to the edge of the puddle. So I'm going to be very, very close to the torch, but never under the torch. So I'm using the molten steel to pull from the filler rod. So once I see the molten steel, I can bring it in and touch it and pull it out. So it's either a tapping motion or a pushing and pulling motion. Okay? And you have to be able to see it, so keep them off to the side like this so that you're looking straight down the center. So if you get your filler in between your torch and the steel, this is what happens. You get these blobs. So this is the steel not melting, and the arc, the heat of the arc and just being close to it is melting the filler, and it's just forming droplets. So if you see this happening, just take your foot off the pedal and you can start again. So if it gets shorter in here, that's fine. You can loosen this. That's just from the tapping, and you can pull it out a little bit and tighten it up again. Alright. So I'm pressing all the way down. When I see the pedal form, I'm bringing in the filler rod. And I'm just going to keep tapping in the filler rod as I move forward. So if you touch these together, or if you touch this to there, just take your foot off. I just did that really quickly. You can take your foot off, and you probably need to change this, but we'll see. So you can remount where you left off, and then you can add the filler in, continue on. And when you're done, just keep moving it as you move your foot off the pedal. So now it will be really hot. You have to go a little bit slower on this side, and it was already preheated from the other side. So this would be normal here. So when you're welding, you want to let it cool in air. You can use compressed air to cool it down a little faster, but you don't want to quench it, because if you throw it in the quench, it can crack the weld. So that's not too much of a concern with the mild steel, but it can be a concern with other materials.